Greetings to my examiner. My name is Teng Chung, and in this final year project 1, I would like to present my thesis, which topic name is ECG narrative, artificial intelligence approach for upscaling ECG manipulation. In this presentation, there are 8 different outlines that I wish to highlight. First will be introduction, consecutively will be problem statement, research objectives, research scope, literature review, methodology, research design and implementation, and last but not least will be conclusion. First, I would like to introduce on the introduction. Introduction is that an electrocardiogram, which commonly known as ECG or EKG, is actually a simple and also painless test that actually assists in measuring and encoding the recording of the heart electrical activity through a series of repeated cardiac cycles. The ECG will actually be done through a small electrode patches that a specific medical professional or technician will actually attach them to the skin of human heart, lungs, and legs. After the electrode patch that have been patched towards the skin of the human heart, the measurement and diagnosis can actually be done by using the ECG measurement, where the medical professionals were actually able to conduct a thorough medical supervision on a patient by determining multiple medical diagnoses on a specific patient. For instance, heart rhythm, risk of heart attack, and also electrolytes abnormalities were actually being part of the medical supervision that a specific medical professional were actually able to detect on the patient through the reading of ECG. The impulses that were actually being displayed in the form of Q, R, and S wave of ECG, which commonly known as QRS complex. Hence, for example, once the ventricle has been contracted, the T wave will actually be displayed to indicate that the electrical impulses have stopped propagating, and then the ventricles will actually relax once again. Hereby is the figure of a normal heartbeat of ECG signals. In this normal heartbeat, we actually can see that P wave and T wave has actually show a normal propagation, where the QRS complex also indicate that the human heart of this specific ECG reading is normal. Next, I would like to present on the problem statement. First problem background that I actually wish to highlight through the research is, first, the misinterpretation of ECG readings. As in the current world context, the conventional ECG can actually be interpreted and derived differently and diversely according to the interpreter experiences and skills in their respective field. This series of problems as well as bottlenecks may eventually lead to different diagnoses, and then at the same time causes troublesome for the medical professionals to have the inability for them to seek common ground, and actually at the same time they actually found it difficult to actually have a common interest on determining what is the medical diagnosis that specific patients have possessed. Next problem that I also wish to highlight is the delayed diagnosis and detection of heart-related diseases. As the current conventional ECG will face limited interpretation, as the current interpretation will actually need to have a thorough discussion among the medical professionals by the means of conventional. The processing time as well as the classification for the heart disease in accordance to ECG will eventually impact and possess risk for the classification of ECG signals to be delayed and at the same time unable to produce the diagnosis and detection for that specific patient at an accurate timing. Next, I will also wish to present on the research objective. Here are some of the research objectives that I wish to highlight. First is to actually to conduct a comprehensive research and review on the existing artificial intelligence algorithm and their respective effectiveness on their techniques. Next, I also wish to evaluate on the benchmark of accuracy, precision, as well as the computational intelligence efficiency for that specific artificial intelligence algorithms. Next, I will also wish to highlight and evaluate on the efficacies and the performance of each and respective artificial intelligence algorithms by utilizing the real-world ECG dataset to cement their respective reliability towards the medical professional. Next, I would like to present on the scope for my final year project research. First, it will more towards the real-world dataset of ECG, which in this case, I actually utilize the PDB-SL diagnostic database to actually be utilized to validate the current effectiveness and also efficiency for the respective artificial intelligence algorithm as well as their respective deep learning method. Next, the research will also opted for multiple and various artificial intelligence algorithms to be utilized in order to evaluate on their respective effectiveness as well as their accuracy in measuring the ECG. Last but not least, the research will also focus on the evaluation of the robustness of respective artificial intelligence in response of the variation on ECG dataset, such as data quality, as well as patient demographic to reaffirm the generalizability of the algorithm against the diversified dataset models. Next, I would like to present on the literature review. So hereby are some of the healthy characteristics for an ECG wave segment. The P wave, the wave must be straight and upright in leads AVF and also between V3 to V6. And the duration need to be lesser or equivalent to 0.11 seconds. Next, the PI interval, the desired time interval for the PI interval to propagate will be between 0.12 to 0.20 seconds. For the QRS complex, the duration will need to be lesser than or equivalent to 0.12 seconds with an amplitude larger than 0.5 millivolt in one standard lead, and it can only be greater than 1.0 millivolt in at least one of the standard lead. Next, for the ST segment, the segment will need to be lean and isoelectric towards the T wave in a specific normal ECG, and the ST segment should never be depressed more than 0.5 millimeter in any single lead. Next, for T wave, the T wave will need to be upright in leads between V2 and V6 and need to be inverted in AVR. The T wave will actually need to be deflected in order to align with QRS complex in at least 5 out of 6 limb leads that has been recorded in a normal ECG. Last but not least, for the QT interval, the duration will need to be lesser than or equivalent to 0.40 seconds for males and 0.44 seconds for females. Hereby are some of the comparison of the artificial intelligence algorithms based on the previous research. Hereby, I will actually downscale on the respective research in accordance to their title and their respective strength, and last but not least, I will actually highlight on the accuracy for each of the respective artificial intelligence algorithms that have been carried out towards the classification of ECG. In this first topic, it consists of the real-time patient-specific ECG classification by a one-dimensional convolutional neural network. Through this research, one of the main strengths is it is able to design for real-time ECG classification, which is crucial especially for timely medical diagnosis. Throughout this research, it has recorded a whopping 98% of accuracy. Next will be classification of ECG arrhythmia through the usage of recurrent neural network. One of the main strengths is it is actually able to handle sequential data, which able to handle time series related data, which one of them consists of the ECG classification. The accuracy is 83%. Next will be the analysis of ECG-based arrhythmia detection system using machine learning. In this machine learning, it actually going to utilize the support vector machine, which in this support vector machine, it actually have its own unique strength, which is able to accomplish high effectability when actually grouping the ECG datasets into distinct and discrete arrhythmia categories. For this, the accuracy is recorded at a very high amount, which is 99%. Next, I will actually present on the title, which is the ECG beat classification by using discrete wavelet transform and random forest. The usage of random forest in this title actually brings a very good strength, which the random forest algorithm is actually insensitive to noise as well as any single interference that have been recorded in the datasets. The accuracy for this title is also very high, which is 99.8%. Next will be the k-nearest neighbor method of analyzing the ECG signal. For this, the algorithm is very straightforward as well as intuitive, making the algorithm to be really easy to understand and digest, as well as able to be implemented in a more efficient and convenient manner. For this, the accuracy has been recorded at 93%. And last but not least will be the hierarchical deep learning with generative adversarial network for automatic cardiac diagnosis from ECG signal. For this, one of the main strengths is it actually has the ability to handle on the imbalanced data issue, as well as the data lacking issue for both robust anomaly detection, as well as disease identification among the ECG signals. For this, the accuracy is also recorded at a very at a very high level, which is 88.5%. Hereby are 6 different artificial intelligence algorithms that I actually wish to highlight. First will be convolutional neural network. Consecutively will be recurrent neural network, generative adversarial network, random forest, k-nearest neighbor, and last but not least will be the support vector machine. First will be convolutional neural network. It actually serves as part of the class and category of deep neural network, the convolutional neural network will actually be more specialized in processing data that actually possess a grid-like topology, such as an image. And for convolutional neural network, it actually able to continuously update and refresh weight metrics through the training with the datasets that actually have been possessed and processed in the convolutional neural network. For this, it actually able to share the weight together to reduce the amount of calculation. Next is the recurrent neural network. For the recurrent neural network, it actually serves as a distinct artificial neural network which utilizes on the sequential data. The output of the recurrent neural network will depend on prior the elements within the sequence. And for the recurrent neural network, it will actually leverage on the back propagation through time, where for this back propagation through time, it actually serves as a unique sequence or algorithm, where this back propagation through time will sum up the error at each time, where the feed-forward networks do not need to sum error, as they will not share any common parameters throughout the layers. Next is the support vector machine. For this support vector machine, you're actually able to carry out data classification, regression, as well as came in handy for outliers detection. And for the support vector machine, it actually aims to find the best hyperplane that is going to be encapsulated in a specific n-dimensional space. Next will be the random forest. The random forest will actually encapsulate and combine the output of multiple decision trees in order to achieve and reach the desired results or even outputs. Normally, there are 2 common methods that are actually going to be executed by the random forest in this prediction phase. First will be either voting or the consecutively will be averaging. Next will be the k-nearest neighbor. For this k-nearest neighbor, it actually serves as a supervised learning artificial intelligence algorithm that will search for intense application in terms of pattern recognition, data mining, as well as intrusion detection. The k-nearest neighbor algorithm will actually operate by identifying the k-nearest neighbor to a given data point using various distance metrics. At this stage, numerous distance metrics such as Euclidean, Manhattan, or Minkowski distances are actually the common distances metrics that are actually going to be utilized by the k-nearest neighbor in order to find out on which of these k-nearest neighbor to a given data point. Next will be a generative adversarial network. For this generative adversarial network will actually consist of 2 neural networks. First will be discriminator and next will be generator. There are a total of 6 discrete processes in executing the generative adversarial network. First process will be initialization. The second process will be the generator first move. And the third process will be the discriminator turn. And the fourth process will be the learning process for the generative adversarial network. The fifth process will be the generator improvement. And the last process will be the discriminator adaptation. These 6 different processes will actually work together in order to ensure that the output that is going to be generated from generative adversarial network is going to be coordinated and at the same time is directly proportional to the input that have been inserted in this generative adversarial network. Next, I would like to present on the methodology that I'm going to utilize and execute in this research. Hereby are 5 different phases inside of my research methodology. So for the inside of phase 1, I'll actually conduct a research topic as well as identify on the objective of this research. And inside phase 1, I'll actually conduct a very thorough literature review to ensure that I have the necessary information as well as able to have more thesis to support on the research that I'm going to conduct. And in the second phase, I'll actually conduct on the dataset preparation, which is I'm going to source on the suitable dataset that is going to be utilized for this algorithm. And next, I will be utilized for the dataset for a thorough pre-processing, as well as able to segment all the datasets and normalize them. In phase 3, I'm also going to utilize on the algorithm selection, and we're going to determine on the performance measurement and metrics determination, and I'm also going to train and test the algorithm. In phase 4, I'm going to utilize the performance measurement and metrics that have been determined in phase 3 for algorithm performance analysis, and also going to present of results from artificial intelligence algorithms. Last but not least, in phase 5, I will actually conduct a thorough report writing and documentation. Hereby are the hardware and software specification that I have been utilized throughout my whole research. For the hardware specification, I have actually utilized multi-core processor, which is the Intel Core i7. And for my laptop wise, I actually utilized 16 GB RAM and 1 TB RAM, 1 TB storage of SSD. And for the software specification, I've actually utilized 4 different software, which is Python, TensorFlow, Jupyter Notebook, and Visual Studio Code. And for the operating system, I have been utilized Windows 11. Next, I wish to present on my research design and implementation throughout my whole final year project 1. Hereby are 6 different processes that have been executed in my whole final year project 1. So first will be data loading. Next will be ECG signal reading and loading. Continue with aggregation of diagnostic information, signal filtering and notching of the ECG dataset, data normalization and R-wave checking, and segment extraction. Next, I would like to present on aggregation of diagnostic information. For the aggregation of diagnostic information, it is actually useful in order to simplify the diagnostic label and the simplification of the diagnostic label so that you're actually able to reduce the complexity of the algorithm to deal with multiple ECG signals pattern that is going to be trained by the respective artificial intelligence algorithm. Next, for the aggregation wise, it actually able to provide more assistance towards the model in creating more robust model for the artificial intelligence algorithms in order for them to analyze the signals. Next, the interpretability of the signals can also be enhanced once the aggregation is completed, as all the distributions of the ECG datasets have been distributed evenly among the algorithm. Hereby is a plotting of the ECG signals through the aggregation of diagnostic. Next, this is the signal filtering and notching of ECG datasets process. For this process, you're actually able to enhance data quality and identify the biologically relevant features that is going to be encapsulated and going to be processed in the upcoming algorithm training and development phase. Several factors such as baseline wonder, muscle noise, as well as power line interference will actually affect the quality and effectiveness for the algorithms to classify on the signals as the data has been interrupted with external factors. Next, the ECG spectrum will actually need to be notched in order to ensure that all the power line of that specific ECG signals will actually be attenuated and being fit at within 50 Hz to 60 Hz. This attenuation will actually effectively remove all the power line interference and will not affect any other parts of signals that have been included in these ECG signals. Hereby of this diagram, it actually shows that the plotting of changes from the original ECG signal to the filtered ECG spectrum, where in this diagram, you actually can clearly see that some of the interference as well as the baseline of wandering have been removed throughout the whole signal filtering and notching process. Next, the data normalization and R checking. For this process, it actually proven crucial as we are going to transform the ECG data scale to a standard scale without distorting any differences in the range of values. The R checking will also be conducted after data normalization in order to ensure that a more accurate R wave detection is actually necessary to align the ECG cycles accurately. In this diagram, it actually can show that the R wave has actually been successfully detected among the ECG signals, where this process is actually proven crucial as it is actually able to train for the upcoming model to have more accurate classification, especially towards the R wave, which is very crucial in order to classify on the ECG signals in accordance to their respective medical diagnosis. Last but not least will be the segment extraction. The segment extraction, the process is also crucial in order to ensure that the data will actually be normalized and able to compare various heartbeats that will actually come from different datasets that have been included. In this segment extraction phase, the time measurement will actually be included and be part of the package in this whole code snippets of segment extraction to ensure that the performance evaluation able to conduct towards the segment extraction on the processing timing and at the same time able to track on the progress of the pre-processing of the ECG signals. Hereby is the segment extraction diagram of that respective ECG signals. Last but not least, I actually wish to present on the conclusion that have been concluded throughout the whole research. The first conclusion that I wish to present, which is the achievement of project objective. A thorough research framework has actually been successfully developed and identified in order to ensure that my research development process and phases can actually be executed in accordingly to ensure that the execution of phase 1 and phase 2 can actually be fulfilled. Next, the phase 2, the data processing phase will actually be executed in order to ensure that all the data will be normalized, segmented, filtered, and preprocessed before the data will be sent to the algorithms for thorough analysis and classification. Next, I will also wish to present on the impact that this research will actually able to provide. The impact of this research is actually able to increase the efficacy as well as the speed for the classification of ECG, especially in medical field, and they're actually able to tailor and spearhead the innovation as well as the development of more robust artificial intelligence algorithms in assisting the medical professionals in classifying the ECG. And last but not least, they're actually able to increase the resources optimization among the medical professionals. Last but not least, I also wish to highlight on the future works and planning for my final year project. In final year project 2, a thorough development of the artificial intelligence algorithm will actually be initiated, and the pre-processed datasets will actually serve as the main datasets that are actually going to be executed and organized for the model training. Next, I will also start to highlight and also start to evaluate on the effectiveness of the performance of artificial intelligence algorithm and by determining their respective performance measurement that have been determined during the phase 2. And last but not least, the documentation for the findings as well as the analysis of the respective artificial intelligence algorithm will actually be carried out to ensure that the proper evaluation of respective artificial intelligence algorithm can be concluded. That's all for my presentation. Thanks and have a nice day.